Problem 8-13. The coefficient of static friction between the drum and the brake is at 0.4. And a moment of 35. Determine the smallest force P. So we pull down on the brake here, which causes friction here, stops the drum or keeps the drum from rotating. Next semester we'll stop things. Determine the resulting horizontal and vertical components of the pin O. Neglect the weight and thickness of the bar. The drum has a mass of 25 kilograms. So let's start by drawing a free body diagram of the drum. So the drum so we got mg down, we got O in the Y, O in the X. A moment. And we got friction is going this way. And we got a normal pushing down. And that is everything. So we can start by looking at this and going, let's sum the moments about O. Because if it's not rotating, the sum of the moments about O has to be 0. So sum the moments about O. We have moment, which is 35. And we have friction. That's going clockwise, so it's negative. Force of friction times the diameter, radius, which is 0.125, and that's it. That equals 0. So the force of friction equals 35 divided by 0.125, which is 280. Now the force of friction is equal to the mu times the normal, and mu is 0.4, and the normal, and the force of friction is 280. So 0.4 times the normal equals 280, and the normal equals 700 newtons. Now they want to find the reactions at O. So I'm going to sum the forces in the x direction. This is 700. This is 280. And in the x direction, we got 280 to the right. And we got OX, and I drew it to the right. Looks like that's going to be wrong. There are no other horizontal forces, so that equals 0. And OX equals negative 280. Now we'll sum the forces in the Y. They equal 0. We have the normal of 700. And we have mg, that's down, and minus OY. And mg, the mass is 25, so mg equals 25 times 9.81, which is 245. So 700 plus 245 is 945, which equals OY. So we're done with the drum. Now we got to find P. So let's draw the free body diagram of the brake. So the brake Looks like that. And it has the force of friction equal and opposite, and the normal equal and opposite. So the force of friction again is 280, and the normal is 700. It doesn't ask for the forces at P, so I'm going to sum the moments about, or the forces at A, so I'm going to sum the moments about A, and the only unknown would be P. So we have P times this distance, which is 300 plus 700, which is 1,000 millimeters, which is a meter. So P times 1. And that's causing counterclockwise rotation about A, so it's positive, minus the 700, and that's times this distance, which is 0.7. And finally we have this force of friction, and that force of friction is acting on this distance there, which is 500, or 0.5, and so that's acting in the counterclockwise direction, so that's positive. The force of friction times 0.5, and the force of friction is 280. All that equals 0, and we can solve for P equals 350.